Students, welcome to Mathgotserved.com. In this clip, we're going to be taking a look at a problem that explores the relationship between similarity and right triangle trig. The question reads in the diagram below, triangle CDE is the image of triangle CAB after a dilation of DE over AB centered at C. Okay, so this smaller right triangle right here is the image after the bigger triangle has been shrunk. Okay, the dilation factor is DE over AB. Question, which statement is always true? So something to keep in mind concerning the relationship of two triangles after one is a result of dilating the other. All right, so this big triangle CAB, after it's been dilated, basically being shrunk, you had this other triangle CDE. So what's the relationship between those two? So a point to keep in mind concerning triangles that have undergone dilation is as follows. So you want to note that when a triangle is dilated, okay, just basically means you generate the image by either shrinking or enlarging the original. Okay, this angle stays the same, but you just change the measures of the size, right? When a triangle is dilated, the image is similar to the original. What does that mean? We are introducing a new term here, which is similarity. Okay, similarity basically means that the corresponding angles are congruent and corresponding sides are in proportion. All right, that's basically what similarity is. And similarity and dilation basically means the same thing. When you dilate an object, they're similar. Okay? All right, so while we're talking about similarity, if you take a look at the options that we have here, we're basically finding what the ratio of the sine of either A or cosine A are. All right, and we're using the ratio from the image. So basically we need to take some information from the okay, actually we're looking at the ratios of the original of the object. So we're going to take some information from the image and use it to answer the question concerning the original. Okay, because sine A, cosine A is in reference to the bigger triangle, which is the original one. All right, so what information can we get from the smaller one that's similar to the bigger that can help us to find which of these ratios is correct? All right, so to draw that connection, we're going to be using an important fact or feature of similar triangles. Since these two triangles are similar because the relationship is dilation, what does that tell us about their sides and angles? Okay, so since they're similar, we can write that triangle, the bigger one, CAB, the notation is like this, similar. Triangle CAB is similar to triangle CDE. Okay, we know this because this is as a result of dilation. That is what dilation tells us. All right. So if these two triangles are similar, what does that mean? We just talked about it. It means that corresponding angles are what? Corresponding angles are congruent. We know this because of the AA, the angle similarity postulate. All right, similarity postulate. If you want to show that two triangles are similar, you can use the AA similarity postulate. Just show that two corresponding triangles are congruent, then that concludes similarity. So we're going backwards in this case. All right, we're using the conclusion to arrive at the hypothesis. So basically, if these triangles are congruent, that means corresponding angles are congruent. If the triangles are similar, corresponding angles are congruent. All right, so we're focusing our attention on, you see, this is sine, cosine of A. So our attention is on this angle right here. Okay, So since these two triangles are similar, what angle is corresponding to A? In the smaller triangle, it's D, right? It occupies the same relative position. These two angles are congruent. All right? Now, if you notice, these ratios, CE, CD, CE, CD, DE, these are all using the small triangle. Okay, so if we can generate the correct sine or cosine ratio from the small triangle, we can use it to determine the sine or cosine ratio for the big triangle since they're similar. Okay, so based on this information that we wrote right here, we know for a certainty that these two corresponding angles are congruent. So angle D is congruent to angle A. Bam, bam. All right, what does this tell us? That tells us that the sine of angle D is equal to the sine of angle A since the angles are equal. All right, and we also know that the cosine of angle D is also equal to the cosine of angle A because the two angles are congruent. All right, so now we're going to use right triangle trig to generate the ratios for sine D and cosine D, and then use that information including along with these equations that we have here to generate sine and cosine A, and then we'll see which ratio is correct. Alrighty, so we're going to be using SOHCAHTOA here. We're just going to be using SO and CA. So let's start off with sine. So what is sine of D? So we're looking at a small triangle now. So for the small triangle, this is the reference angle, angle D. So this side that's right here, that's opposite that angle, is the opposite. All right, the O in SOHCAHTOA. The longest side, the side opposite 90 degrees, is the hypotenuse, and the other side is the adjacent. So there goes the O, A, and H for SOHCAHTOA. So sine D is the opposite over hypotenuse, right? Bam, bam. From so means sine equals opposite over hypotenuse. Now the opposite is EC, all right, or I can just say CE to match the options. CE over hypotenuse, CD. That's for sine D. All right. But since sine D is equal to sine A, this follows that sine A, by substitution, is also equal to CE over CD. Isn't that something? Now let's take a look at cosine. Cosine D, now for this one we're going to use CA in SOHCAHTOA, okay? So CA is adjacent over hypotenuse. So adjacent over hypotenuse. Now, if you go back to the triangle, the adjacent is DE, all right, relative to angle D, and the hypotenuse is still CD. Bam, bam. So cosine D using the small triangle is DE over CD. So this follows that sine of A, angle A in the big triangle, is going to be the same thing as DE over CD because angle D is equal to angle A. Okay, sorry, it's not sine, it's cosine right here. So cosine of D is equal to cosine of A. Cosine of A. Bam. Right there, because angle D and angle A are the same. So cosine D is going to be the same thing as cosine A. All right. Okay, so DE over CD. So just to help you see what's going on, just notice that. See how these two match? They match because these two angles are the same. Same here. These two match because these angles are exactly the same. All right, so now that we've generated our ratios for comparison, we're going to be able to determine what the correct answer is. So sine A is CE over CD. Do we have that? Sine A is CEOO. Voila. The answer is option number 1. So let's just take a look at the cosines just to make sure that we didn't make a mistake. Cosine A is DE over CD. This one is wrong. And this one is, oh, this is close. DE over CE. No, it's DE over CD. So this is wrong also. All right, so the answer to this question is option number 1. Thanks so much for taking the time to watch this presentation. We really appreciate it. Don't forget to help support our channel. Tons of support resources can be found at mathgotserved.com. Do check it out. Or you can take a look at the links in the description below or scan the QR code. If you have any questions or have any special requests, specify it in the comments section below, or just let us know how your day is going in general. Thanks again for watching. We will see you in the next video. Goodbye.